Hello, everyone. Welcome back to SAT Math Question of the Day. This comes from the educated side of the SAT. Spoiler alert, this could be on a Blue Book test. Okay. A local transit company sells a monthly pass for $95 that allows an unlimited number of trips of any length. Tickets for individual trips cost $1.50, $2.50, or $3.50 depending on the length of the trip. What is the minimum number of trips per month for which a monthly pass could cost less than purchasing individual tickets for trips? Interesting
Oh,
problem. Seth, why don't you try it?
yeah. Well, it's clear that to achieve the minimum number for which the monthly pass costs less, you pack in as many $3.50 trips as you can. And
It's
so
not that
the first step is you divide, the price of the unlimited ticket by $3.50, and we have to do the division. You want to do it with a calculator for me?
And my pleasure. My pleasure.
Yeah, calculate it.
95 divided by 3.5 is 27.14. But
Wait, 27 points. How much?
14, but you always redo it. 27.14, yeah.
Okay, so to achieve the minimum number of trips, where the pass costs less, what you do is you first take 27 trips at 350.
Yep. Okay, let's multiply that out.
Uh,
Which is $94.50.
$94.50.
Right, $94.50. Yeah.
And let's see, at this point, if you paid that, you would pay less if you paid per ticket, right? So, but they ask, oh, what's the minimum number of trips for which the pass costs less? So what you do is you add on one trip. It will be at least 50 cents, so that if you add on one trip, if you did it individually, doesn't matter how expensive it is, the cost of those 28 trips would exceed $95. So
Right,
the answer is 28.
28 times 350.
It's 28
I know,
is the answer.
The answer is 28, right, yeah. So just 28 times 350 is $98. But if you pay $95, it's a nice deal.
No, but you could also do 27 trips, and then take a cheap trip,
Oh, right,
and
yeah.
you'll save money.
That's right. 27 trips is $94.50 plus $1.50 is $96.
Yeah.
So it's 27 3.5s and 1.5. You extend this out to get $96.
Yeah, that's right.
Right.
Easy problem.
Well, it's not that easy because you got to think about what minimum number of chips means. Is that you have to make sure to divide that by 350, not by $1.50.
Well, you always have to think.
Yeah, you always have to think, right? Yeah, but it does take a little bit of
let me scribble this. It's 27 at 350.
Yeah.
I meant it 350.
And then I was actually not
plus 1 at any price.
Right. Yeah.
150 to $2.50 or 350.
Yeah.
We'll give you the minimum number of trips for which the pass is strictly less expensive than the individual trips.
Yep. Yeah. So
add them up and get 28. That's just the answer.
So in some ways, the main strategy here is just a little bit of common sense. But you have to read the problem carefully. It does take a while to digest what they're asking. The minimum number of trips. It's interesting. The minimum number of trips.
The idea, the intuitive idea is that to minimize the number of trips where the bulk unlimited pass would be less expensive is to use it for the most expensive trips.
Right, exactly. So they're opposite each other. The smallest means you have to use the largest. Right? The smallest, what is the fewest? Fewest, right? What is the fewest number of trips per month?
The fewest number,
Yeah.
which when multiplied, no, yeah, the fewest number.
Yeah.
No, I think we have to actually say it carefully.
I know we do. Yeah.
Say it carefully. You want to calculate a collection of trips that is more expensive than the monthly pass, but has the fewest trips.
Right.
So you want to calculate a collection of trips that is more expensive and has the fewest trips.
Right.
So you make each trip the most expensive possible.
Right. Yeah, because that's right. Yeah, that's right. Yeah. So my suggestion, at least, is if you're having trouble digesting what to do here, try to rephrase the sentence, maybe in slightly different words that may make it more obvious to you or more clear to you what to do. Like you may want to think about this and say, well, this is really the fewest. Maybe the word fewest to some people will jar them into doing it correctly as opposed to minimum number. I like the word fewest. I think fewest is more intuitive. What do you think? I think the word fewest
like minimum.
Really? Oh, I like fewest. But the idea is that if you're reading a problem and you don't quite get it, change some of the words to words that are synonymous, keeping the idea of the problem the same. And maybe a synonymous word will lead you to getting help you doing the answer the right way. Also, try to really get a sense of it and maybe make yourself part of it. Like, I am doing this, I am buying this, and I'm going on the ferry or whatever, or taking the boat. Make it as a you thing, so you get an intuitive feel about it. Okay, so that's right. We always ask the questions first, and then we'll look at their answer. Okay, so calculator. Yeah, maybe. I mean, calculator certainly could help.
Oh, you need to divide 95 by three and a half.
Right. Yes, and you could do that.
And a calculator really helps with that.
Right. Yeah.
To see how close.
Yeah.
To see the quotient. Right. And then you need to get it. You have to get it to the. You have to get it to the. You have to know whether it's exactly an integer.
Yeah. Yeah. Right.
Or whether it's greater.
Right.
Than whether it's a fractional quantity greater than an integer. If it's an integer, then the integer you get is the answer. If it's a fractional number, if it's an integer plus a fraction, then the number you need to give is 1 plus the integer portion. In other words, you do the division must be rounded up.
Right.
The quotient must be rounded up to get the answer.
Is there a pattern to this question? No, there's no pattern to this question. There's nothing specific about these numbers that makes it super easy to do. The division, you got to use a calculator. There's no necessary pattern to this thing.
Don't say you got to.
Okay.
Some people can do it.
Some people can do it, yeah. Do you see this question from school? Not really. But any educator that we encourage the educators, if anyone's watching this, to use some of these questions in your class, because they're good questions and also they help people get ready for these standardized tests. But this is an unusual question that you don't normally see in school. I guess that's it. And then, of course, we ask starting with the guess, impossible. This is 3-response question. You can't do that.
No, you can guess. There's another way of doing it by guessing.
Oh, start with a guess?
Maybe it's 20. Maybe the answer is 20. So,
time-wise, it makes no sense.
So 20 at 350 is pretty easy to calculate.
So that's $70.
That's $70, right?
$70, right.
That's not enough. So maybe try 5 more.
25, right? Yeah.
How much is that? That's half of 350. It's one.
You forget it.
$10 and $17.50.
Right.
Which gives you up to $87.50.
Right.
And then you add on, well, maybe another one will get you to $90. And another one.
$91, Seth. You made a stupid mistake.
Okay, $91.
Yeah, it's not
plus $3.50, which gives you $94.50. So that gives you within one trip full
right.
of the price. So how many 350s? 25 plus 2 more, 27.
Right.
And then you add one, and they get 28. So you could do it that way.
But the other way you could do it is you can start out playing with the problem. The verb is playing with the problem, and then once you start playing with it, you could see, oh, I know what I need to do. I need to divide 95 by 350 to get this number. So you can certainly start playing with it, which is a great way to do problems when you're stuck and you have no idea what to do. The main idea, why did they put this on the test? What was there? What were they trying to see if you knew what to do? Well, first of all, digest a word problem that's sort of unusual that probably you've never seen before. Understanding what minimum means and how to get the fewest number of things, given the fact that you have a limited amount of money and the things cost different amounts, and the key here is that you only use this one number really to help you get the answer. I mean, it's basically a word problem, and I think they were just trying to figure out how good you are, what your skill set is in solving word problems. What do you think? Why do you think they put this on the test? What were they trying to see if you knew what to do? Or is that a silly
SAT questions?
Okay, fine, whatever. Okay.
Well, I think a better, more realistic problem. The more realistic problem is you're given how many trips at each price you normally take in a month,
right?
And then decide whether it's if it's less expensive to buy the pass,
right,
or to pay for the trips individually.
Right. This is the Saturday price. This is the Sunday price, and this is the weekday price. And they
didn't say that. No,
I'm making up the problem.
It's a length.
Seth, I'm making it up as you would say, and you would say, well, I take 3 Saturday trips, 4 Sunday trips, and 12
how about
weekday
3
trips.
short trips?
Yeah.
3 short trips. How many? Yeah. 3 short trips, 4 medium length trips,
right,
and 5 long trips.
Right. Yeah. And if I do that every month, does it make sense to just pay, or does it make sense to pay the $95? Right. Yeah. That would be a problem that you would actually have as like a real person. Yeah.
Yeah.
Okay. Let's see how they do it. Do they wonder if they, let's see how they do it. Okay. So let us see. Okay. What do we do here? We go like this. Oops. No, we kill the annotation. We kill this thing, and we go like this. Sorry, everyone. Okay, good. So notice they call it a hard question. The answer is 28. Congratulations, Seth. The minimum number of individual trips is less than the cost of for which the cost of the monthly pass is less than the individual cost of tickets can be found by assuming the maximum cost of the individual. Good job, Seth. That's exactly how you started it. Good job, Seth. You killed it. You nailed it just like they did. Well, they did it just like you. Event tickets costing $350 a person 1 month. The inequality. Ooh, they set it up as inequality. Represents the situation. Oh, I can't stand when the variable is on the wrong side of the inequality. As far as I'm concerned. I don't like this. This is confusing. I always like 350 and it's greater than 95. But anyway, come on. You don't have to use an inequality. It confuses things. If I can tell by Seth's body language, he doesn't like inequalities. Too powerful.
Well, the inequality that I was concerned with was 95 is less than 3.50 times n of 350 trips plus other tickets, plus others. 150 times n of 150 plus, how much? 250 times n sub 250.
Oh, right.
This is the real inequality.
Oops. And these are the SAT people. They should know better.
Yeah.
The inequality.
And then you want to minimize the sums of the little n's.
Right.
And then minimize the sum of the little n's by taking the biggest little n,
right,
the biggest value you can for the n350.
Yeah.
And then you still won't satisfy the inequality.
Yeah.
Unless you could add in a 1 to one of the other ends and then satisfy the inequality.
Bringing in the inequality seems to complicate things. I don't know if anyone's really.
Well, it's a complicated situation.
Yeah, it is a complicated situation.
The inequality I wrote it expresses exactly what the situation is. Right.
Yeah. So they sort of blew it. They didn't really do it quite right. Yeah. Yeah.
So they don't say.
That's annoying.
They don't say. Okay. So I think they're right. It's less than. Can be found. It can be found by assuming the maximum cost of individual tickets. So you assume that you're going to.
Right.
That's what they said. So they use that intuition that the maximum cost is attained by the fewest tickets to be more expensive than the pass is to. They assume that you would achieve that using the maximum price tickets.
Right.
That's what they did.
Yeah. So by assuming, they essentially crossed out what I did. They just ignore these. Yeah. Okay. So I think we're done with this. Yeah. So carry on, everyone. Do the Blue Book tests. Do all the Blue Book tests. Seth, did I tell you that we haven't met in a while? Did I tell you that when people should know by now that the SAT updated 3 of the Blue Book tests? Did I tell you that?
No.
Yeah. I guess they heard that, Blue Book, okay, everyone, Blue Book 4 and Blue Book 6 on the math side are the closest to the SAT. There's some really hard questions on Blue Book 4 and Blue Book 6 on the math side. Those model what you can expect on the actual test. Blue Books 1, 2, and 3 were relatively easy on the math side, so the SAT swapped out 2 questions on each test and added harder questions on those 3 tests to make those tests. Yeah. So now maybe Blue Book 1, 2, and 3 are going to model closer to what the actual SAT is. Take all those Blue Book tests. Take those questions seriously. We've heard rumors that the actual tests, they use questions very similar to those Blue Book tests. So practice on those. And if you're not sure of any topics, go to Khan Academy and do their digital practice. And do as many questions as you can. And also practice the stuff you're good at so you can do them a lot faster so you have time for the few harder questions or some of the harder questions. So I guess that's it, right? Please, I'm Joel.
That's
I
it.
have a PhD in mechanical engineering. My brother Seth has a PhD in math. Seth's been teaching computer science at SUNY Albany for many years. He's now retired. We're here. We try to meet every day, although sometimes we don't. And we go over an SAT math sample question, and we try to go over it with different ways of doing it. And most importantly, we really try to understand what the main idea is, so that we don't know what's on the test. We know these ideas will be tested. So that's why we spend our time on one question, going over different lenses and different approaches to dealing with the problem. Okay, everyone. So I guess have a great day. Please leave comments on our videos. We take all the comments very seriously. And I guess that's it, right? We're done for today.
That's it.
That's it.
That's
We're
it.
done for today. Okay, everyone. Have a great day. Bye-bye.